So we're going to jump into solving some trig equations today. And basically, if you can solve any of these equations from algebra, you can solve a trig equation. It's really just solving equations and then doing a little bit of trig at the end. So for what you want to remember is that in a trig equation, the variable that you solve for is like a trig expression. So if you notice, I got these two equations down here. And on the left, see how I have 7 sine x minus 3? So that sine x is the same as the x here. So I'm going to solve the equation as if I'm just solving for x. And then I'm going to do some inverse trig at the end. That's really what's going on. So if I'm going to solve this equation here, what I'm going to probably do is I'm going to subtract 2 sine x from both sides. Just like in the equation on the right, I would subtract 2x from both sides. Maybe add 3 to both sides. So when I solve that equation, I get 5 sine x equals 2. So the sine of x equals 2 over 5. So now you just got to do your inverse trig. It's not too bad to do it all. Let's go to our calculator for a minute. So first of all, I'm also noticing that I'm solving for x in 0 to 2 pi, which means I'm going to get an answer in radian mode. So yep, my calculator's in radian mode. That's good. So let's solve this equation. Let's go inverse trig, and we'll do 2 divided by 5, and I get 0.411516. Okay, but here's something that we got to think about. So that's one of our answers. I think if we go to 3 significant figures, we got 0.412. Now, something else to remember is that sine is also positive. Besides in quadrant 1, sine is also positive in quadrant 2. We're going to have to pay attention to this thing today. So what I need to do now is I need to find out what would be the quadrant 2 angle whose sine is also 2 over 5. And what you might remember is that in quadrant 2, I should start off in quadrant 1. If the angle is theta in quadrant 1, in quadrant 2 it's 180 minus theta, or pi minus theta. In quadrant 3, it's 180 plus theta, or pi plus theta. The quadrant 4 angle is found by doing 360 minus theta, or 2 pi minus theta. So here's my thinking. I know that in quadrant 1 sine is positive. I know the quadrant 2 sine is positive. And since my answer of 2/5 was a positive value, I know I'm also in quadrant 2. So I'm going to go to my calculator, and in my calculator, I'm going to do pi. Let's see, where's my pi button? I'm going to do pi minus my answer. So to get answer, I can go control negative, which takes the previous line's answer. Or you can just type A and S. So in quadrant 2, the angle is 2.73 radians. So there's going to be 2 answers here. To 3 significant figures, my answers are 0.412 radians and also 2.73 radians. So let's keep solving some equations. The next one we want to solve in between 0 and 360. So now I'm in degree mode. So let's take a look at this equation. It's equal to 0. I got a sine x on both sides, or in 2 different terms. I can do some factoring here. So I'm going to factor out a sine x. So if I'm going to do some factoring, I'm going to write this equation as sine x times another expression equals 0. Sine x is my greatest common factor. So when I factor a sine x out of the first term, it leaves 1. And factoring out of the second term leaves me 2 cos x. So now if I'm solving an equation, I have to use that multiplicative property of 0. No, I think it's a 0 property of multiplication, where if 2 things like sine x and like 1 plus 2 cos x are equal to 0, it means that I can set each term equal to 0. And I can solve each of these equations. Now, I don't know if I need to really use my inverse trig for sine x, because I know where sine equals 0. I know from my reference numbers that the sine of an angle is 0 when x equals 180 degrees and when x equals 0 degrees. I mean, if you want to go to your calculator and do inverse sine of 0, you're going to get 0. But remember, it's also equal to 180. If I solve this equation, I got to subtract 1 from both sides. So I get 2 cos x equals -1. I'm going to divide each side by 2. So I get cosine x equals -1/2. And that's another angle that I know. I know what angle has a cosine of -1/2. I really know what angle has a cosine of 1/2. So remembering this ASTC thing, the cosine of my angle is negative. So I got to be in quadrant 3 and quadrant 2. That's where cosine is negative. But I also know that the cosine of an angle equals 1/2 when my value of x is equal to 60 degrees. So that's my quadrant 1 angle. If I'm going to find my quadrant 2 angle, remember quadrant 2 is 180 minus quadrant 1. So one of my x values is going to be 180 minus 60, or 120 degrees. The other angle, let me just scroll down a little bit. The other angle is going to be 180 plus 60. There's my quadrant 3 angle, 240 degrees. So that exposes a little trick that I like to do. When I have an angle whose cosine or sine is negative, what I like to do is I like to find the quadrant 1 angle. And then I like to move it to quadrant 2 or 3 or 4, depending on my needs. So the next one we're going to solve, from 0 to 2 pi, I'm in radian mode now, is a quadratic equation. So that might be best solved by doing some factoring. So when I factor this equation, it's kind of similar to factoring this equation. 2x squared plus x minus 1 equals 0. Think about trying to solve that equation. That's what I'm going to do here. So if I do a little bit of factoring for that equation, let's see, there's no GCF, so I'm going to make 2 sets of parentheses. I'm probably going to need a 2 cos x and a 1 cos x. I need numbers that multiply to -1, so I'm going to have a 1 and a 1 there. And this is probably going to be my positive value because that gives me a 2 cos x. And then I have a -1 cos x. So check it by distributing it through. Use whatever factoring method you like. And that equals 0. So let's see if we can solve this equation now. Again, that 0 property says that I can set both of these factors equal to 0. So I want to do 2 cos x minus 1 equals 0. And I want to do cosine x plus 1 equals 0. So let's see, if I solve this equation on the left, I add 1 to both sides. I divide by 2. I'm going to get cosine x equals 1/2. Okay, I know that. That's another angle that I have. So, and I'm in radian form this time. Maybe you cheat and you do degree mode if you want, and you remember that it's 60 degrees. 60 degrees in radian form is pi over 3. Now, let's go to what the other quadrant where cosine happens to be positive. Remember that cosine is also positive in quadrant number 4. So the other value of x that's in quadrant 4 is going to be 360, or 2 pi minus pi over 3. 2 pi is like 6 pi over 3's, and if I subtract 1, I get 5 pi over 3. Solving the equation on the right, if I subtract 1 from both sides, I get cosine theta equals -1. So cosine theta is equal to -1. I don't want to write theta, I want to write x. We'll make that an x. When x equals pi, or 180 degrees. You can solve that equation in your calculator if you wanted to as well. If you're in radian form, I don't think it's going to give you pi. Let's check it out and see what it's going to give us. If I do inverse cosine of 0, I'm sorry, it's not 0, it's -1. Okay, so it does give me pi. Cool. All right, solving some more equations. We're doing great here, friends. Let's check out this one. Oh boy, another factoring one. Another quadratic. I get them in degree mode. What's up with this guy? Changing from radians to degrees every time? Hey. All right, so notice that this is not equal to 0. I like my quadratic equation set equal to 0. So I'm going to have to move that 2 to the other side and get 3 sine squared x minus 5 sine x minus 2 equals 0. Okay, so again, let's go through some factoring here. There's no common factor, so I'm going to make 2 sets of parentheses. Let's see, I'm going to need a 3 sine squared x. So that's probably going to be a 3 sine x and a 1 sine x. And I need numbers that multiply to 2. Okay, but when I then do my other combinations, they got to combine to a -5 sine x. So do I put the 2 here and the 1 here? Let's see. When I combine those, that gives me a 2 sine x, and that gives me a 3 sine x. There's my 5 sine x. But the problem is that -2 at the end there, that tells me my sign's got to be different. There's no way that I can combine a 2 sine x and a 3 sine x to give me a -5 sine x, but still make the 1 and the 2 product of those positive. I'm sorry, the product of those two negative. So I got to erase those two and maybe swap them around. Because this is going to give me now a 6 sine x and a 1 sine x. And if indeed I want to get this to be a -5, I need a -6 and a +1. So this is going to be my +1, and that's going to be my -2. Holy cow, do you remember all that from factoring? Yikes. Fun stuff. Hey, but I know what to do from here now. So now I'm going to set each factor equal to 0. And I'm going to start on the right side for a second, because I'm going to add 2 to both sides. And I'm going to get sine x equals 2. So watch what happens when I go to my calculator for a second and I try to do this. This is going to be an interesting thing. If I do the inverse sine of 2, it gives me an error. And if you think about what the sine graph looked like, wasn't a sine graph always bound between +1 and -1? So this is like a domain error. I can't have an angle whose sine is 2. So what I'm going to say here then is, for this part of the equation, there's no solution. The only solution is on the left side when I subtract 1 and divide by 3, and I get sine x equals -1/3. So before I solve that, let me think about what quadrant I'm going to be in. This tells me I'm going to be in quadrant 3 and quadrant 4. So what I'm going to do first is I'm going to find the angle that's in quadrant number 1. I'm going to need a little bit of room here. Let me move this down a little bit. So what I'm going to do first is I'm going to get the angle that's in quadrant 1. And then I'm going to move that angle around. So I'm going to do x equals inverse sine of +1/3. Because I want to know the quadrant 1 angle first. So now when I go inverse sine of 1/3, oops, I'm in radian form. Let's go to degree form. And let's do this again. So I get about 19.47, 19.5 degrees. So this is going to be my angle in quadrant 1. My quadrant 1 angle is 19.5 degrees. But I want the quadrant 3 angle. So the quadrant 3 angle is 180 more than 19.5. And I know I could do this in my head, but I'd rather just type it in here. And I get 199.5. So my quadrant 3 angle is 199.5 degrees, or maybe we'll call it 200 degrees if we're going to 3 sig figs. You probably have to go to like 200 point if we're going to 3 sig figs. I also want my quadrant 4 angle. So remember, quadrant 4 is when you do 360 minus your angle. 340.5, we'll say 341 degrees. So those are the two angles that solve that equation. All right, even more. Oh, mama. But holy cow, this one, crazy enough, is cosecant. Don't worry, I'll show you how to handle it in a second. First of all, recognize it's in degree mode. It's a quadratic equation. Set it equal to 0. So I want to get cosecant squared x minus, I keep writing s's, minus cosecant x minus 2 equals 0. So let's do our factoring. So I'm going to get cosecant x, probably minus 2, and then cosecant x plus 1. If I check that real quick, the negative 2 times 1 is negative 2. And this gives me a negative 2 cosecant x and a positive 1 cosecant x. And they combine to give me negative 1. Cool. All right. So if I start solving this equation then, cosecant x minus 2 equals 0. So cosecant x equals negative 2. If I solve the other one, I'm just going to get them to the same spot. Cosecant x equals negative 1. Now, remember that the cosecant function is the reciprocal of the sine function. So what these equations tell me is that if I'm using cosecant, let's take the reciprocal of both sides. So the reciprocal of cosecant is sine. So this becomes sine x equals, take the reciprocal of 2 and get negative 1/2. And I'm remembering now that cosine or sine is positive in quadrants 1 and 2, negative in quadrants 3 and 4. So therefore, I know I'm going to be in quadrants 3 and 4 here. My quadrant 1 angle, when sine is a positive 1/2, is 30 degrees. So if I move that to quadrant 3, my x value is going to be 180 plus 30, or 210 degrees. My quadrant 4 angle, the other place where sine is negative, my angle is going to be 330 degrees. The final side here on the right, again, let's do a reciprocal. Oh, the reciprocal of negative 1 is just negative 1. And where does sine equal negative 1? Sine's equal to negative 1 at 180 degrees. That looks like a 6. Let's make it a 0. 180 degrees. Beautiful. 210, 330, and 180. Those are the three values that solve this equation. Boy, we've been pushing. Let's do one last one together. And thankfully, it's going to be in degree mode. It's another quadratic equation, so maybe we're thinking about factoring it. But there's a problem. I don't have any numbers that multiply to 3 and combine to give me a 5. So do you remember that we might have to use the quadratic formula? Oh, mama. Mama. Ooh. Didn't mean to make you use quadratic formula. Oh, boy. So remember, A, B, and C are the coefficients of your variables. And our variables are like sine and cosine. So let's first do the quadratic formula. So my value x, or my value sine x, is going to equal -5 plus or minus the square root of 5 squared minus 4 times 1 times 3 all over 2 times 1. And let's see if we can simplify this a little bit. We're going to get -5 plus or minus, let's see, 25 minus 4 times 3 is 12. So 25 minus 12 is 13 over 2. Whew, look at that. Okay, before I get going on my calculator, let me remember what quadrants I'm going to be in here. So now let's go to the calculator and figure out what this value is. And remember, we got to do it in 2 different parts. So let's first do the -5 plus the square root of 13 over 2. -5 plus the square root of 13 divided by 2. So as a decimal, I get this. All right, now hold on. That tells me that since it's negative, sine is going to be in quadrant 3 and quadrant 4. So what I'm going to do is I'm going to take this answer as a positive value. Here's a nice easy way to do that. I'm going to do negative answer. I'm going to take that value and I'm going to do the inverse sign of it to figure out what quadrant I'm in. Or to figure out what my quadrant 1 angle is. So this is my angle in quadrant number 1. But I know I'm in quadrants 3 and 4. So I better do 180 plus that answer. So here's one of my angles. One of my angles to 3 sig figs is 224. Let's go back here. So one of my angles is 224 degrees. The other angle, I'll do it on the calculator. I want to do 360 minus, and watch what I'm going to do. I'm going to hop all the way up there, and I'll just take that whole expression there. So my other angle is 316 degrees. Okay, we're halfway done. And you're like, what? Let me show you why. What I should have written down over here was that this is for x equals the inverse sine of -5 plus the square root of 13 over 2. Because remember, we have the plus and the minus. So we need to figure out what's going to go on if we do the inverse sine of -5 minus the square root of 13 over 2. So let's go back to our calculator and let's work through that. First of all, let's figure out what is the value of -5 minus the square root of 13 divided by 2. We can celebrate. Well, you're like, what? Why can we celebrate? Well, remember that the range for sine is between -1 and +1. If we get a value that's less than -1 or greater than +1, we're going to get a domain error. So there's only 2 answers to this. To this one, there's no solution. And there's no solution because negative 5 minus square root of 13 over 2 is less than negative 1. There we go. We did a lot of solving trig equations here, boy. I showed you a lot of factoring. I showed you the quadratic formula. I showed you radians, degrees, move into different quadrants. Sounds like we need to practice a little bit.